Welcome to Classes with Atish. Today's lecture is about mole concept. We'll go over all the details that you need to understand this, and then we'll solve a lot of problems so your understanding of this concept is absolutely clear. So with that, let's get started. The first concept that we will introduce is atomic mass. Now what is atomic mass? Atomic mass is very simply the mass of an atom. So let's see quickly what comprises of an atom. Okay. So in an atom we know there is a nucleus, there are protons and neutrons in the nucleus. The protons are positively charged particles, neutrons have no charge. The mass of a proton and mass of a neutron are roughly the same. Okay. Now around the nucleus there are electrons which are orbiting. Okay. So let's see. This is the lowest energy level orbit, and then let's also draw another higher energy level orbit. Okay. Now let's say we take an example of an atom like the carbon atom. Okay. In the carbon atom we have 6 protons and we have 6 neutrons, and also we have 6 electrons. Now the electrons, like I said, are orbiting around the nucleus. So in the lowest energy level of the orbit there are 2 electrons, and in the next one we have 4 electrons which are orbiting. This is a very rough model. We'll go over more details about the model of an atom in later classes, but what I want to show here is there are 6 electrons that are orbiting around the nucleus. Now the electrons are negatively charged particles. So roughly this is what a carbon atom is comprised of. So what is atomic mass? Atomic mass is nothing but the total mass of the atom. So if we add up the masses of all the protons plus mass of all the neutrons and the mass of all the electrons, then we should have the atomic mass. Is as simple as that. Okay. Now mass of protons in terms of grams is 1.67 into 10 to the power minus 24 grams. Mass of neutrons is also roughly same as the protons, so we will assume it's the same as the mass of proton, which is 1.67 into 10 to the minus 24 gram. Mass of electron is however much lower. It is 9.1 into 10 to the power minus 27 gram. So when compared to the mass of proton and the mass of neutron, we can safely neglect the mass of the electron. So when we calculate the atomic mass, we typically don't need the mass of the electron. Okay. Now, so if carbon atom has 6 protons and 6 neutrons, so what is atomic mass of carbon? It's 6 protons and 6 neutrons times 1.67 into 10 to the power minus 24 grams. Now obviously it is very inconvenient to deal in grams because this will be 12 into 1.67 into 10 to the power minus 24 grams. Now as you can see, it is quite inconvenient to deal in grams. So what we define is another unit called atomic mass unit. In short, this is called AMU. Okay. Now what is atomic mass unit? So let me just give you a little idea about this one. So if I ask what's the weight of average adult man, we will say roughly maybe 70 kgs or 80 kgs. We don't say it's 70,000 grams, right? It is very inconvenient to say that. So kg is a known, or pound is the known unit in which we describe a man's weight. Similarly, atoms are so small, gram is too big a unit to describe an atom's weight. So we define something called atomic mass unit. So how do we define atomic mass unit? To define atomic mass unit, we need a reference. Now the reference we choose is the carbon 12 isotope of carbon. Okay, so we assign one atom of carbon 12 to have an atomic mass unit of 12 AMU. So what is 1 AMU? 1 AMU is 1/12 the mass of one carbon 12 atom. That is the formal definition of AMU. What is it in terms of grams? It turns out to be 1.67 into 10 to the power minus 24 grams. So if we go back here, then we can write atomic mass of carbon is either this in grams, or we can simply write 12 AMU. Sometimes it's also written as 12U for short. Okay, so that is what is atomic mass unit. Now everything is in relation with carbon 12 atoms mass. So that's the reason it's also called relative atomic mass. Okay, now for some of the elements like hydrogen, relative atomic mass is 1. For carbon it's 12, oxygen is 16, nitrogen is 14, calcium is 40, sodium is 23, magnesium is 24, and such. Okay, now in your exams the relative atomic masses will be given to you, and you will have to compute based on the given relative atomic masses. Okay. So next step is molecular mass. So molecular mass, as the name suggests, it applies for molecules, and it is nothing but the sum of the atomic masses of all the constituent atoms. It's as simple as that. The formal definition of molecular mass is, however, how heavy one molecule of that substance is compared to 1/12 the mass of one carbon 12 atom. Okay, so let's compute the molecular mass of some simple molecules. So molecular mass of water, which is H2O. Okay, so how do you find that? So here we have two atoms of hydrogen atom and one atom of oxygen atom. So we can write 2 into atomic mass of hydrogen plus 1 into atomic mass of oxygen. Okay, what is the atomic mass of hydrogen? It's 1. And what is the atomic mass of oxygen? It's 16. So this is 2 plus 16 or 18. Okay, now it's not enough to just write 18, we should also write atomic mass unit, or this can also be represented as 18U. Okay, similarly let's find the molecular masses of, let's say, carbon dioxide, ammonia, sulfur dioxide, sulfuric acid. Take some time to pause the video and find out the molecular masses of each of these compounds. In fact, I should also give you the atomic mass of sulfur is 32. Okay. For H2SO4, we have hydrogen, we have sulfur and oxygen. We have two atoms of hydrogen. Hydrogen's relative atomic mass is 1. Plus we have one atom of sulfur. So 1 into 32, because relative atomic mass of sulfur is 32. And oxygen, we have 4 atoms. So 4 into oxygen's relative atomic mass is 16. Okay, I will give you another example of molecular mass. Let's find the molecular mass of this compound, Al2SO4 thrice. Okay, this is aluminum sulfate. Now you will need the atomic mass of aluminum. Let's say the atomic mass of aluminum is 27. Okay, now here you'll have to be a little bit careful. There are 2 atoms of aluminum, so 2 into 27. Now there are 3 atoms of sulfur. It is not 1 atom of sulfur, there are 3 atoms of sulfur. So 3 into 32 plus there are 4 3s are 12 atoms of oxygen. Okay. So this is how you should be computing the molecular mass of a compound like aluminum sulfate. Maybe you can try a few more. Find the molecular mass of C6H12O6, okay, and CuSO4 5H2O. Okay, given the atomic mass of copper is 63.5. Okay, there is another term I want to introduce to you. It's called formula unit mass. So this applies to ionic compounds. So in case of ionic compounds, we calculate the formula unit mass. It is nothing but just adding the atomic masses of the individual atoms that form the ions. So for example, CaO, calcium oxide, this actually exists at calcium ions and oxide ions. However, to calculate the formula unit mass, it's as simple as calculating the molecular mass of CaO as if this was a compound. So that's the reason it's called formula unit mass. So this will be one atom of calcium times 40 plus 1 atom of oxygen, which is 16. So 56 AMU. Now I will introduce 2 new terms. One is called gram atomic mass and another is called gram molecular mass. Okay, both are actually very simple. If atomic mass of, let's say, oxygen is 16 U or 16 AMU, then gram atomic mass of oxygen is 16 gram. Okay. Similarly, if molecular mass of, let's say, H2O we know is 18 U, we say gram molecular mass of water is 18 gram. Okay, so just remember these two terminologies. Now I will introduce a very important concept, so listen to this carefully. When we say 1 dozen, what does that mean? It means the number 12. Okay, it can be 1 dozen of apples, 1 dozen of oranges, it can be 1 dozen of anything. It means 12 apples, 12 oranges and such. Okay. Similarly, 1 mole, okay, is also a number. It is just a number, nothing else, just like a dozen. 1 mole's value is 6.022 into 10 to the power 23. It's obviously a very big number, but this is all that it means. If I say 1 mole of carbon atoms, it means 6.022 into 10 to the power 23 carbon atoms. If I say 1 mole of apples, it means 6.022 into 10 to the power 23 apples. It is just a number. If you remember this, okay, then a lot of things will become easier and you will not get confused. So always remember, 1 mole is nothing but just a number. Okay, it's an important number, but remember it's just a number. Okay. Okay, let's say we have a very simple reaction. Hydrogen and oxygen, they're combining to form water. So 2 hydrogen molecules combine with 1 oxygen molecule to form 2 molecules of water. Okay, now it is very difficult to actually see 2 molecules of hydrogen combining with 1 molecule of oxygen and forming 2 molecules of water. It is very hard to see that, it's very hard to measure that. Okay, rather it's much more easier to measure, let's say maybe 2 grams of hydrogen combining with X grams of oxygen to form maybe Y grams of water. Okay, so the reason we take this big a number is because these numbers that you see, you can very well replace 2 molecules of hydrogen by 2 moles of hydrogen combining with 1 mole of oxygen to form 2 moles of water. Okay, so when I say 2 moles, remember moles is nothing but a number. What does it mean? 2 times 6.022 into 10 to the power 23 molecules of hydrogen gas, hydrogen molecule, is combining with 6.022 into 10 to the power 23 molecules of oxygen gas to form 2 times this number of molecules of water. This number is called Avogadro's number and is denoted by sometimes as Na, sometimes by N0. Okay. So what is the significance of mole here is, in any chemical reaction, individual substances, they combine in fixed proportions, and those fixed proportions can be represented in terms of mole. Next concept I will introduce is molar mass. What is molar mass? It is nothing but mass of 1 mole. So if I say molar mass of hydrogen gas H2 is mass of 1 mole of hydrogen H2, okay, which means mass of Avogadro number of 6.022 into 10 to the power 23 molecules of H2. we can also write mass of 6.022 into 10 to the power 23 molecules of H2. Why molecule? Because H2 is a molecule, right? If it was molar mass of, let's say, hydrogen atom, then it will be 6.022 into 10 to the power 23 atoms of hydrogen atom. Okay, remember this is just a number. Okay, so 1 mole of the substance, that's what it means. So molar mass is represented in grams per mole. Okay, so if I say what is the molar mass of oxygen atom, it is nothing but 16 gram per mole. What is the molar mass of H2O? It's 18 gram per mole. Okay. Now I just want to tie this up with something. So if you remember, we said 1 atomic mass unit in terms of gram, 1.67 into 10 to the power minus 24 gram. Okay, so 1 mole of, let's say, protons or hydrogen atoms, okay, will be how much? 1.67 into 10 to the power minus 24 gram times how many atoms of hydrogen are there in 1 mole? 6.022 into 10 to the power 23 atoms. So that many grams per mole, right? Now if we multiply this, what happens? It is 1 gram per mole. So that's the reason if 1 hydrogen atom weighs 1 AMU, then 1 mole of hydrogen atoms will be 1 gram per mole. So from that it follows that whatever is the atomic mass of oxygen, the molar mass of oxygen will be simply gram. The same number, gram per mole. Same thing. Whatever is the molecular mass of a substance, for water it's 18U, then the molar mass of water is 18 gram per mole. Okay? Okay, let's say I give you a problem. Calculate the molar mass of CO2. What will be the answer? It will be carbon is 12 plus 16 times 2. 16 is oxygen's atomic mass times 2. That many grams per mole, or 12 plus 32, which is 44 grams per mole. Okay. So molar mass is nothing but mass of 1 mole of carbon dioxide. Now suppose we have a problem like find number of moles of oxygen atoms in 64 gram of oxygen. How do you do that? Simple formula to remember: number of moles is equals to the total mass divided by molar mass. Okay, what's the total mass that's given here? It's 64 gram. What is the molar mass of oxygen atom? It's 16. So number of moles is 4. Okay, so remember this: number of moles is total mass by molar mass. Okay, now let's solve a few more questions like this. Let's say find number of moles of H2O molecules in 36 gram of H2O. Again, simple: number of moles is total mass, which is 36 gram by molar mass. Okay, so 36 gram. But what is the molar mass of water? Let's find that out. 2 hydrogen atoms plus 1 oxygen atom. So this is, molar mass is grams per mole, and this is grams, right? So 36 divided by 18 moles or 2 moles. Okay, now let's ask the question in a little different way. Let's say find in 36 grams of water, how many moles of oxygen atoms, 2 moles of hydrogen atoms. Okay, 3 number of H2O molecules, 4 number of hydrogen atoms. Okay, 5 mass of hydrogen atoms, and maybe 6 gram atoms of hydrogen. Okay, take a moment to pause the video and see if you can figure out all of these questions. Okay, how many moles of oxygen atoms? Now we know in 36 grams of water we have 2 moles of H2O molecules. Now in each molecule there is 1 oxygen atom, so then there will be 2 moles of oxygen atoms. Okay, now how many moles of hydrogen atoms? Now for each molecule of H2O there are 2 atoms of hydrogen, so it will be 2 moles times 2, which is 4 moles of hydrogen. Okay, number of H2O molecules. Now each mole is how much? Is 6.02 into 10 to the power 23 molecules. So in 2 moles it will be 2 times 6.022 into 10 to the power 23 molecules. Okay. Number of hydrogen atoms. Now in each molecule of H2O there are 2 atoms of hydrogen. Now there are so many molecules of H2O. So how many atoms of hydrogen? So 2 times this, 2 into 6.022 into 10 to the power 23 atoms of hydrogen. Okay, mass of hydrogen atoms. Great. So in each mole of hydrogen atoms, we have 1 gram per mole is the molar mass of hydrogen. Now how many moles of hydrogen atoms are there in 36 grams of water? There are 4 moles, so times 4, so we have 4 gram of hydrogen atoms. Now gram atoms of hydrogen, this is a new term again. It looks like gram atoms of hydrogen is nothing but how many moles of hydrogen. We have already calculated that it's 4. Okay.
Let me introduce another concept of mole. 1 mole of any ideal gas at standard temperature and pressure, which is defined as 1 atmospheric pressure and 273 Kelvin, exactly occupies 22.4 liters. This is applicable only for ideal gases and at STP.
Number of moles is total volume divided by 22.4 liters, but this is only applicable for 1 ideal gases and at standard temperature and pressure. Now this 22.4 liters, this is also called molar volume. Okay, this is called molar volume. Okay. Now what if that ideal gas was not at standard temperature and pressure? Then you will have to adjust the molar volume based on Charles law and Boyle's law, which is PV by T is a constant. So this is the molar volume, and depending on what pressure and temperature we are calculating the new molar volume at, which is, let's say, P1 at P1 pressure and T1 temperature. If the new molar volume is V1, then that is how we will calculate. Find volume occupied by 88 grams of carbon dioxide at STP. Okay, pause this video and see if you can solve this. We'll use the formula number of moles equal to total volume divided by molar volume. Now this is what we have to find, the total volume. Molar volume at STP we already know, this is 22.4 liters. So what is remaining to be found out is what's the total number of moles in 88 grams of carbon dioxide. So what is the total number of moles in 88 grams of carbon dioxide? We will use the other formula, total mass divided by molar mass. Okay, So what's the total mass that's given? It's 88 gram. What is the molar mass of carbon dioxide? It's 12 plus 2 times 16, which is 32 plus 12 is 44. So 88 divided by 44 is 2. So there are 2 moles in 80 grams of carbon dioxide. So the total volume will be 2 times 22.4 liter, which is 44.8 liter. Find number of moles of ozone gas in 5.6 decimeter cube of ozone at STP. So again we'll use the formula number of moles is equal to total volume divided by molar volume. Okay. Total volume is given 5.6 decimeter cube. Decimeter cube is same as liter. Divided by what is the molar volume? It's 22.4 liters. This is 0.25. Now if I ask you how many ozone molecules are there in 5.6 decimeter cube of ozone at STP. So once you have found out the number of moles, number of O3 molecules will be what? 0.25 into Avogadro's number Na. If they ask you how many number of oxygen atoms are there, then it will be 3 times 0.25 Na, because there are 3 atoms of oxygen in ozone, in one molecule of ozone. Now there is another very important application of mole concept in stoichiometry. So what this says is substances react in fixed proportions. Nitrogen reacts with 3 hydrogen, and this is a reversible reaction to form 2 molecules of ammonia. Okay. Now all are gaseous. Okay. So what does this chemical reaction or equation mean? It means one molecule of nitrogen gas reacts with 3 molecules of hydrogen gas to form 2 molecules of ammonia. It can also mean, or it can also be interpreted as 1 mole of nitrogen gas reacts with 3 moles of hydrogen gas to give 2 moles of ammonia. Now, it does not mean 1 gram of nitrogen gas reacts with 3 grams of hydrogen gas to give 2 grams of ammonia. That is wrong. You always have to convert into moles. Okay? Alright. So let's take an example. So let's say the problem is find the mass of hydrogen needed and mass of ammonia produced from 14 grams of nitrogen. Okay. Now, first thing is, how many moles of nitrogen gas are there? So how to find how many moles? Total mass by molar mass. So total mass of nitrogen, let's say moles of N2 is, total mass is 14 divided by, now atomic mass of nitrogen is 14, but 2 atoms of nitrogen are there in one molecule of N2. So 2 into 14 is the molar mass. So basically this is 0.5 moles. Okay. Now if 1 mole needs 3 moles of hydrogen, how many moles of hydrogen needed is, 1 needs 3, so 0.5 will need 0.5 times 3, or 1.5 moles of hydrogen is needed. Okay. Now how many moles of ammonia produced? So if 1 mole of nitrogen produces 2 moles of ammonia, so 0.5 will produce 0.5 times 2, or 1 mole of ammonia. Now the question is, find the mass of hydrogen needed. So mass of H2 needed is number of moles. So total mass is number of moles times molar mass. Molar mass of H2 is 2, so 3 grams. Similarly, mass of ammonia produced is number of moles times molar mass of ammonia. What is the molar mass of ammonia? Nitrogen is 14 plus hydrogen is 3, so 17, so 17 grams. Okay, so see, like I mentioned before, 1 mole of nitrogen gas combines with 3 moles of hydrogen gas to produce 2 moles of ammonia. We always need to convert into moles. This is very, very, very important. Okay. Now you can see that 14 grams of nitrogen is combining with 3 grams of hydrogen to form 17 grams of ammonia. Those ratios only apply to moles, not masses. Okay, so it only applies to number of molecules that are combining. So substances react in fixed proportions of not mass but molecules or atoms. Okay, so with that, pretty much we have covered most of mole concept. In our next video, we will solve a lot of questions around this mole concept and test our understanding.